assessing the safety, sustainability, and accessibility of public buildings for disaster evacuation. During disasters, people affected by disasters are evacuated and temporarily shelved to designated evacuation shelters or sites in the Philippines. Evacuation centers must be safe, sustainable, and accessible to the community. Evacuation centers must be appropriate to specific hazards like floods, earthquakes, or typhoons. This study presents a rapid hazard-based assessment related to safety, sustainability, and accessibility of evacuation shelters based on hazard type. The basic framework used for the risk assessment due to hazards is as follows. Hazard times vulnerability is equal to risk. For specific hazards like earthquake, wind, or flood, indicators are identified and multiplied by specific weights. Similarly, evacuation centers or buildings have vulnerability indicators and corresponding weights. The product of the indices obtained for hazard vulnerability gives us the risk. The following scale is used. If the risk index is less than 20, then there is a high safety rating, which corresponds to a 5-star. A risk index greater than 20.0 corresponds to an evacuation center with a low safety rating or a 1-star rating. The methodology was applied to an evacuation center in Pasig City. And these are the seismic hazard and vulnerability assessment. This corresponds to the seismic hazard assessment, and these are the parameters corresponding to seismic vulnerability assessment of the structures. The seismic risk index of this building is 6.875, which is the product of the hazard index, seismic hazard index, and the seismic vulnerability index. This is the flood hazard and vulnerability assessment, and these are the parameters for hazard assessment, and these are the parameters for flood vulnerability assessment. For this building, the flood risk index is equal to 2.6. This is for the wind hazard and vulnerability assessment. These are the two parameters used for wind hazard assessment, and these are the wind vulnerability assessment of the structure. The wind risk index is equal to 9.0. Sustainability and accessibility assessment is also done. For sustainability assessment, the parameters are shown in this table corresponding to living space, sanitation, solid waste, etc. For accessibility, this is the accessibility of the evacuation center with respect to the communities, which includes the access roads, the travel time, location of evacuation center, and evacuation routes. The sustainability index is 3.62 and accessibility index is equal to 3.73. Final results of this assessment is for this particular building, the earthquake safety rating is equal to 3-star, the flood safety rating is 4-star, wind safety rating is 3-star, sustainability rating is 3.5-star, and accessibility rating is 3.5-star. Conclusion. So LGUs can identify evacuation centers or public buildings and determine their star rating based on the specific hazard like typhoon, flood, or earthquake. And these evacuation centers are assessed based on that hazard and also sustainability. So LGUs can show a map as shown, an example, where the evacuation centers with symbols of the hazards to guide and inform the community that evacuation centers are hazard-based. Thank you very much.